So good morning, everyone. A very warm welcome back of our Imagery and Remote Sensing webinar series. My name is Samkit Bagmar, the host. I contribute to the Imagery and Drone Solutions business here at Esri India. So it's fantastic to have you all back with us today. I can see a lot of new joinees as well today. Before we get started, just a couple of housekeeping items. First, if you have any questions during the presentation, please feel free to drop them in the chat box, the Q&A box at any point. We'll address as many as possible live as well as towards the end of the presentation. Secondly, for those asking about slides, recordings, yes, we will be sharing full recordings of all the webinars that we did post the webinar series, right? So we'll be sharing it all to all the attendees on your email. Also, we'll be having it on our webpage on the webinar pages of Esri India. To ground today's session, let's take a quick look back at where we have been over the past 2 days. On day one, we kicked off with GeoAI and deep learning, showing how artificial intelligence inside ArcGIS automates complex feature extraction, object detection, land cover mapping directly from raw imagery. On day two, that is yesterday, we moved from individual desktop workflows into intelligence, enterprise-grade intelligence. We looked at how combining ArcGIS Pro Image Analyst with ArcGIS Enterprise along with Image Server allows organizations to stream dynamic image services, scale analytics, and collaborate across within teams without having data silos. Today, on day three, we step into a topic that connects all of us, all these words together. It's ArcGIS Reality. So creating a foundation for digital twins. A digital twin is a living digital replica of the physical world, but a digital twin is also as good as the reality capture data powering it, right? As it forms a foundation of the digital twin. ArcGIS Reality is Esri's photogrammetry suite and a reality mapping suite designed to turn raw satellite, aerial, drone imagery into survey-grade 2D, true orthos, DSMs, DTMs, point cloud, photorealistic 3D meshes, and 3D Gaussian Splats as well today. To serve different project scales and operational needs, the suite includes 4 key technologies. The first one is ArcGIS Drone to Map. It is an intuitive desktop application built specifically for rapid drone photogrammetry. It is optimized for offline processing right in the field so that you can turn drone imagery into high accuracy 2D and 3D maps without any internet connection. SiteScan for ArcGIS is our end-to-end MIDI-empaneled cloud-based drone mapping software. It manages everything from flight planning, flight tracking to automated cloud processing and instant web-based visualization and analytics. The third offering is ArcGIS Reality for ArcGIS Pro. So this is an extension that brings reality capture directly inside your ArcGIS Pro desktop environment. It lets you combine satellite, aerial, and drone imagery to produce high-density 3D meshes through orthos while leveraging ArcGIS Pro's advanced spatial analytics. The next offering that we have is ArcGIS Reality Studio. This is our flagship standalone application engineered specifically for massive site-wide, city-wide, or even country-wide reality mapping. This is optimized for precision and speed. It handles multi-camera drones, aerial arrays across multiple flights to build photorealistic 3D foundations for large-scale digital twins. Today, we will see how these tools come together to build true representations of the real world, enabling you to run analytics, simulate scenarios, and make smarter operational decisions before making changes on ground. To lead us through today's presentation and live demonstrations, I'm delighted to introduce our speakers to you today. Ashish Kumar, he is from our defense pre-sales team, and Abhishek Yadav from our imagery pre-sales team at Esri India. Both of them bring extensive expertise in photogrammetry, reality mapping, 3D GIS architectures, and will show you step by step how to bring these digital twin foundations to life. So without any further delay, let's dive in. Ashish, over to you.
Thank you so much, Samki sir. So I will start with the agenda. That what are the things that we will be covering in the session. So I will start with the image management capabilities in ArcGIS and following with the digital twin and what is the reality mapping, with following with the project and the desktop demonstration of SiteScan ArcGIS Drone to Map, ArcGIS Reality Studio, and ArcGIS Reality for Pro. So let's start with what are the management content of system of insights. So organizations today collect vast amount of imagery from satellite, drones, imagery, surveys, radar, and other sources. ArcGIS image management provides a centralized platform to manage, organize, and process this content at scale. Once managed, the imagery can be transformed into dashboards, reports, applications, and analytical products that generate actionable insights. This enables organizations to move beyond managing data and establish a true system of insights that derives informed and timely decision making. So I have a question for you all, that what is a digital twin? So mirroring the real world with GIS, a digital twin is a virtual representation of reality, including physical objects, processes, and relationships. When built on a foundation of geography, it becomes a geospatial digital twin. So, geospatial. What do you mean by geospatial? Accurate representation of complex system requires a robust maps and spatial analytics from geographic information system technology. Uh, and with respect to time awareness, GIS-based digital twins go beyond 3D models as they reflect change over time, showcasing historic, current, and future states of a particular region or an area. And it is totally scalable from a single facilities to a large build and natural systems. Geospatial digital twins can scale to meet changing needs. And all these digital twins can be integrated to create all the different urban planning, smart cities, natural resources, and design and engineering with respect to all the different types of data. Like you can integrate BIM data, LIM data, CIM data, and create a different decision making and business proposition. So let me deep dive into the definition of reality mapping. Reality mapping is the process and the capability of capturing the accurate digital representation of the world using images, LiDAR, or you can integrate both of the data. So traditionally, our foundational layers has been built using raster and vector datasets. With ArcGIS Reality, we can enhance these layers by creating detailed 3D meshes and segmented 3D objects. These objects can be classified into buildings, roads, vegetables, and other features, forming the basis of comprehensive digital twin. By consolidating reality mapping, 3D reconstruction, segmentation, and feature classification under a single umbrella, ArcGIS Reality provides a foundational framework for developing accurate and scalable and intelligent digital twins. So more important than what it is and why it matters. At Esri, we help people transform the world by unlocking the full potential of location intelligence to solve problems. As a part of effort to better understand our natural and built environment, we believe that an accurate and up-to-date digital representation of the world is a critical to making informed decision. Reality mapping allows you to create or update foundational content through highly automated processing using different types of sensors like drones, airplanes, satellites, and you can create 2D products as well as 3D products. The 2D products includes true orthos, multispectral data, and you can include different types of sensors like thermal sensors. You can integrate to create and analyze a particular area. As well as you can also include the videos and the geospatial data that can be associated with the right orientation data that can be integrated and create the oriented images as well. So we enable reality mapping through ArcGIS Reality, a software suite designed to serve the diverse needs of user. ArcGIS Reality supports a variety of inputs, as I have already mentioned, like drone, aerial, satellite, including with different types of sensors like RGB, thermal, multispectral, and LiDAR. It processes this data to generate different types of output, and you can also manage the sets of individual still images or video in a geospatial context through oriented imagery catalogs. All these data products then seamlessly feed into a GIS and a BIM to perform a variety of analysis tasks from inspection to the feature extraction. To move further, now let's take a closer look into the outputs that you can get from the ArcGIS Reality. First, there are true orthos, which provides a pixel accurate image layer. This means each pixel in the image is spatially consistent and with mapping data and elevation. And true orthos are also consistent between multiple flights. You can use them to perform precise measurement and apply change detection and deep learning algorithms. Second, ArcGIS Reality lets you to create accurate 2.5D digital elevation models. These can be used for topographic surveys and hydrological analysis. And in 3D, you can create point clouds to provide highly accurate representation of reality. They can be used for 3D point measurement and point cloud classification. You can also generate a mesh as photorealistic carrier format for your geodata. It's an intuitive way to empower non-specialists to interact with your data and lets you integrate your existing metadata. You can generate a fully 3D mesh for a site and a citywide mapping, as well as a 2.5D mesh, which is suited for a countrywide mapping. Now, also, we have also integrated a new layer that is Gaussian Splats within our new upgrade. So I'll explain you about more the Gaussian splats. It is a highly realistic 3D layer. Traditionally, 3D models typically represents objects and terrain using meshes, which are made up of vertices, edges, and triangulation polygons. Creating these models often requires significant processing to generate and optimize the mesh structure, and fine details can sometimes be lost during the process. In contrast, Gaussian splats are a next generation 3D visualization technology that uses millions of intelligent 3D points instead of traditional polygon meshes to create highly realistic digital representation of the real world. This approach preserves fine details, complex structures, and natural features with exceptional visual quality. So these layers can be used for the infrastructure management, urban planning, asset management, where there are thin structures like utility towers and the wire that are hanging through the city that can be monitored and visualized at a greater extent. Now let's talk about some DSM based true ortho. Importance of true ortho. With true ortho, every pixel will appear in its geometric correct position. There are not spatial distortion like object lean or seam line being used. Instead, every object is shown from the top of down perspective. This makes it ideal for things like feature extraction and detecting some objects on the ground. As you can see, this is a traditional orthomosaic on the left hand side. And the right hand side, we have a true ortho that is derived from the reality. So as you can see, there are every pixel is its geometrical corrected position, and there is no object lane between the buildings. As well as you can, while the extraction of the features or building footprint extraction, uh, you can see there is no object lean line between the buildings, and it is ideal for accurate feature extraction and vector overlays while you do the analysis of a particular area or an object. So I'll show you some more example of the true ortho. As you can see and observe some of these towers that are present in this building, and I'll show you the geometrically corrected in the next slide. So as it is visible that behind these towers there are some layers and objects that are present. So once these are pixel accurately corrected, you can measure and extract these feature according to the true ortho visualization. Now I'll talk about the reality mapping. So reality mapping capabilities, which enables the creation of 2D and 3D geospatial products from satellite and imagery collected at any scale. From individual sites to entire cities, states, and even nationwide mapping programs. The key message here is any data at any scale, whether the source is drone imagery, aerial photography, or satellite imagery data. ArcGIS Reality solutions can convert raw imagery into a high quality geospatial content for visualization, analysis, and decision making. Starting at site level solutions like ArcGIS drone to map are ideal for processing drone imageries to generate orthomosaics, 3D models, and site specific intelligence. As we move larger projects covering cities and regional areas, ArcGIS Reality Studios comes in and enables scalability reality mapping workflows capable of handling extensive aerial and drone datasets. And for statewide and nationwide programs, ArcGIS Reality for ArcGIS Pro provides enterprise-grade reality mapping capabilities, allowing organizations to generate and manage large-scale 3D content within the ArcGIS platform. The images on the right shows the example of reality mapping outputs. I'll start the recording. As you can see, there are a different level of imageries that you can see, and these are the outputs that we have generated from different types of sensors. Now I'll invite Abhishek for demonstrating and enhancing the capabilities of side scan and drone to map. Over to you, Abhishek.
Thank you, Ashish, for a wonderful presentation for the introductory part of the mapping suite. And here I will take over and show the capability of side scan for ArcGIS and drone to map. Please, my screen is visible. There are two applications which you get in ArcGIS ecosystem, which is called SiteScan for ArcGIS and Drone to Map for ArcGIS. So here, imagine you are a site engineer or you are managing a very large site where situation and conditions changes on a daily basis. What you need to do to inspect and analyze those situations and conditions of your project. Where here you can utilize your drone imaging capability and you can plan your drone fleet, and you can capture your data through ArcGIS site scan, capturing data where you can plan your flight plan, and after capturing, you can process those data into products like 2D orthomosaics, true orthos, and different geospatial products, and then analyze the drone imagery at scale. Here we should keep in mind that this entire integration is over cloud, and you do not use your local computing resources. After computing all these drone imagery at a scale, you can invite different users and different project planners and create a shared link between those organizations. And you can also publish this products and this missions within ArcGIS Online and ArcGIS Enterprise ecosystem. Uh, at scale, where you plan your mission, you analyze your products, and you deliver the solution, ArcGIS SiteScan comes into play. Here, I will take you through a quick glimpse how ArcGIS SiteScan works. So, having ArcGIS SiteScan deployed at your cloud, you get to see this launch page where you can see different projects aligned. To create one mission, you get to a new project, you name those projects. So, sorry for the glitch. So, once having ArcGIS SiteScan at your play, you get this launch page where you can see the base maps of the world, and you get the list of your projects and missions. You can also create your missions from here, where you can see already existing missions, and you go on to new project. For clicking new project, you can also see your team members who are in this mission, and you get to choose who will be the part of your mission. So this provides you a launch page from where do you want to start your project and mission. So Delhi would be my launch city. Once I save this, my project and my mission will start from here. Once having a mission delivered at output, you get to those missions. You can see different photos by the plan you created for using ArcGIS SiteScan. You can see all these photos aligned together. You can see your mission area, how much area has been captured. Along with this, you get to see the elevation profile of your project area. Here you get to see the elevation model right at a single push of a button. Along with this, you also see the processed drone true ortho, which have been processed using the drone images which you captured. And if your fleet has the thermal sensor mounted, you get to see a thermal image as well, where you can use this thermal image to analyze the hotspot. Along with this, you can see a timeline swipe between many changes which have occurred throughout the timeline in your project, and to see many changes and to report those changes to upper level and decision maker, you can use this slide to swipe timeline button and analyze those changes in your mission. Moving further with the cloud map, having those images at the place, you see these point clouds where your project area looks like this, the area which has been captured. This allows you for some geometric analysis where you can capture the angle of your objects within the scene. You can calculate height, you can measure those objects, and all those geometric capabilities such as area calculation, elevation profile calculation. Here you can see this, you can capture this area like this. clicking on those points. For distance, you can see how this tool works. It gives you a certain distance between those profiles between two different boundaries, which allows you to monitor certain we have one elevation profile chart where you can visualize how your different features within those projects look like. This elevation profile provides you a in-depth aerial visualization and height visualization over the scene, and you can see how these solar panels are elevated. If there is any misadjustment or any faulty adjustment, you can analyze using this tool, and you can generate a report follow. Moving ahead with the 3D project, here you get a 3D mesh where you can see different features aligned and different products within this scene. So this produces a very exact and true to the geographic location 3D mesh where you can turn around, pan around, and inspect your features within the scene. So this was one capability which ArcGIS Pro sites can provide you, where you can process your drone images and do all the processing in a cloud environment. Now I will take you to the another application of ArcGIS Pro, which is drone to map. So drone to map is another application which allows you to process 2D products such as true orthos and as well as 3D products for advanced processing like point clouds and 3D mesh. ArcGIS Drone to Maps provides you the capability to analyze and process all your drone images in an offline processing environment, and there with additional capability to analyze and produce analysis report of multispectral images and thermal images as well, where you can do work on applications such as site inspections, construction monitoring, crop health monitoring, and environmental assessment as well. ArcGIS Drone to Map allow you to export your product and project in ArcGIS Pro, ArcGIS Online, and ArcGIS Enterprise. Moving ahead to another demonstration for ArcGIS Drone to Map, you see this landing page of ArcGIS Drone to Map. Here, there are many pre-processing templates available for your various requirements. If you want to choose between rapid processing, you want to produce 2D project or 3D project, or do a batch processing. To start with your project in an offline environment, you can name your project whatever you wish to. You provide the image or you provide the folder that contains the image. Go on setting with the coordinates and create a project. Once having done with project creation, you can manage manage the products which you want to produce. Here I am producing true ortho and 3D products. So here you can see after creating project, you can manage what product you want to generate. You can choose between those products and generate your those geospatial products. Here you get the capability and tool set to edit and do certain metadata change between in your images, you get to edit the products available which has been generated, and you can go on to measure different kinds of features within your scene available. Once set, I'll show you the different products. Here you can see image centers dotted in blue line, flight line which has been captured using image metadata, and different control points. Having these information, this drone to map processes the accurate and exact geospatial products such as true ortho and digital surface model. This true ortho looks like this. You can see different features within this scene, and there are many stockpiles and many constructions going on. Some constructions have been already completed and some are in progress. You can go on and measure different volumes like this, and you can know how much stockpile, how much rubble, how much raw material is available in the sea. Here you can see 3,400 cubic feet of raw material of sand is available. You can measure distances, how long this feature is. You see in feet and in different angles as well. Suppose you want to measure some area over your image, you can go on this and click certain buttons, and you get to see an area calculated on a push of a button, which says this project 2,290 meters square feet. Here you see a digital surface model of the area with different elevations, which says maximum and minimum elevation height available using this true earth. Here you see 3D point cloud and 3D mesh of the same project. Where you see where you see this stockpile, you can visualize it and visualize the 3D mesh and do certain analysis. You can calculate height, measure vertical height, and all those features within the sea. So having drone to map and ArcGIS at your environment allows you to process your drone images and get an exact geospatial product within your online cloud environment and in your offline desktop environment using drone to map, where you can share your mission with your team, and you can integrate your project with ArcGIS Pro, ArcGIS Online, and ArcGIS Enterprise. So this capability allows you to generate some inspection report, generate different kinds of report on construction sites and site inspections. I'll hand over the session to Ashish, and he will lead you through the reality mapping workspace. Over to you, Ashish.
Thank you so much, Abhishek, for a detailed demonstration of the two products like ArcGIS for site scan and drone to map. Now I'll go forward and demonstrate the capabilities of ArcGIS Reality for ArcGIS Pro. So one of the key advantage is its capability and ability to work with multiple imagery sources, whether the data is collected from drones for site level analysis, aerial surveys for city scale mapping, or satellites for regional coverage. ArcGIS Reality for ArcGIS Pro provides a unified environment for data processing and analysis. Another important capabilities is workflow automation. Using ArcGIS geoprocessing tools, organizations can automate data processing tasks, improve efficiency, reduce manual effort, and ensure consistency across large mapping projects. So this includes also the true ortho mapping tools for a large area 2D mapping, including satellite imageries. Now I'll demonstrate some capabilities in the product as well. So, give me a thumbs up if my screen is visible. Thank you so much. So this is the interface of the application. As you can see, this is ArcGIS Reality. ArcGIS Pro and with the Reality extension. As you can see in the licensing, my Reality license is available, and I'm licensed with ArcGIS Reality extension to use the capabilities. So this is the total interface. So if you wanted to create some new workspace, so once you go onto a Imagery tab, it will ask you to create a new workspace. So when we go onto the workspace, the product will ask you that what are the workspace that you wanted to create and what are the sensors that you wanted to use to create a particular type of imagery. So my workspace type is reality mapping. And as you can see, there are different sensor types that it supports to process the large image and different types of imagery. As you can see, drone, satellite, aerial digital. Once you set onto your parameters, you can add the parallel processing factors according to your machine and the hardware requirement. So I'll switch on to drone imageries. These are the information. Once you can do the addition, you can add different types of imageries. Either you can add your particular file or particular imagery, as well as you can include the folder structures for without using the manual interventions of your imageries. So here is for drone, as well as you can also process and create the outcomes of your satellite imageries. So as you can see, there are numerous amount of sensors that are included within the software. So as you can see, these are the numerous amount of sensors. Not only one sensor, you can add multiple type of sensor within the same project, where it can generate a project within the same environment. So as you can see, there are different new sensors that have been added recently, like the Cartosat imagery. So you can process that sensor as well. So in the interest of time, I have already processed some of the imagery. So as you can see, this is an example of black sky imagery that we have used to create the different types of outputs. So once the reality mapping has been used, it can generate the true orthos that I have already explained to you in the further slides. So this is an example of true ortho, as well as the DSM output that it can generate. So I'll move on to show you the example of DSM. It will show you that what are the heights of a particular buildings within the area, and what are the elevation profile of that particular area, as well as the 3D products that I'll show you. So once you go on to the 3D layer, you can see the same layer has been derived to create the 3D mesh of that particular area. So you can see and analyze that what are the height of a particular building within this respective area, and you can do the further type of analysis using these images. So I wanted to show you some more examples using the drone images. As Abhishek has also shown you the examples. So the yellow points that you are seeing are the images that have the drones have captured. So this is an example of drone imagery while we have processed the drone images. So the yellow dots are showing the images that have been captured from a drone, and the orange path that you can see is the flight path of the particular drone that has been flight through this area. So after going on to reality, you can select the numerous amount of multiple products that a user can generate according to their needs. So these products include the digital surface model, digital terrain model, true orthos. Uh, these are the 2D products, and the 3D products are DSM mesh, point cloud, 3D mesh, and the Gaussian splats layer that have been added recently for doing the analysis. I will be showcasing a demo for that particular layers that will show you a contrast between the meshes and the Gaussian splats. So once the user is satisfied and the outputs that they need to create, so again, in the interest of time, I have already calculated and derived some products. I'll show you the examples. So this is a true ortho of a particular region that I am showing. So this is Rajiv Gandhi International Stadium that is in Raipur, Uttarakhand. So from creating these imageries, as you can see, this is the true ortho that is it has been generated, and also this is the DSM that it has created. So as you can see, once your foundational data is clearer, the similar output is generated from the different types of sensor. As compared to satellite, the drone images are more clearer and spatially well organized. So output has been contrast to them. So I'll show you the example of the 3D images that it has generated. So this is a point cloud of that same region that I'm showing previously in the 2D workspace. So using the point cloud, you can either classify them into different classes by using deep learning packages, and you can classify the grounds, classify buildings, classify the overlaps between the same region, as well as there are different types of symbology that you can choose from your images. This is the symbology that I have used to showcase the different levels of point clouds to show the elevations. Now, once I click on to showcase in RGB, so as you can see, my point clouds has been derived and symbolized according to the RGB class. And you can symbolize the size of your points and allocate the points that you wanted to see according to your rendering system as well. So for the same point cloud classification, I'll show you the 3D mesh of this same layer. As you can see, this is the mesh that I have generated. For the same region. And not only the visualization, we can do the different types of analysis on the go. For example, I'll show you some different analysis and the simulations that you can do on the fly. So I'll show you some exploratory analysis. Like, for example, if a person is sitting on this particular stadium, that what will be the view shed of from your particular seat, and what are the view shed area that you wanted to see from that particular building. So once I click a point, it can generate the DS, the visible sides of your area, and user can directly move those points that what are the visible layers from that particular point and the analysis, and you can manually manage and do the heading and tilting of your point and the view shed. Also, there are different types of analysis that user can do on the globe. For example, if you wanted to do and simulate a particular type of weather condition or simulate a flood condition over the area, so you can simulate different types of analysis. Like you can do the flood simulation from, for example, I wanted to do a flood simulation of this particular point using my analysis layer. I can select this particular point and create a area to do the flood simulation, and it will ask you the different parameters that what is the rain coverage that it has created, and what is the rainfall rate you wanted to ingest, and infiltration according to your area, that you can do, and do the simulation analysis on the mesh that you have created. Now I'll show you the example of the Gaussian Splats layer that I was talking about. So in the traditional ways and the traditional meshes, there are different types of distortions that you can see on the most of the layers, like vegetation. As you can see, these are the vegetation layers that you can see. The beneath the vegetation, there is a broccoli effect that all these distortions are clearly visible, and these are not demarcated properly. So I'll show you the contrast between the traditional meshes and the Gaussian splats. So once I'll enable the Gaussian splats here, you can see the trunks of the vegetation and the particular layers that you can see clearly visible, and all the things and clouds are derived more accurately and visually appealing. So these Gaussian splats layer are more relatable in the utility sectors and the vegetation classification layers that a user wanted to classify and do the analysis. So I'll show you some more examples. So as I zoom in, these are the layers that you can see in the towers. So these generation are more accurate in the point clouds. So now I'll move on to the different application. So now I would like to talk about the ArcGIS Reality Studio. So Esri's scalable reality mapping solution designed for processing large volumes of aerial imageries or satellite imageries, creating a highly accurate 3D geospatial products at city, regional, and a national scales. Another major advantage is its ability to deliver survey grade accuracy, making it suitable for application that requires precise measurements and high quality spatial data. To handle the computational demands of large imagery collections, ArcGIS Reality Studios leverages local distributed processing, allowing multiple users and multiple processing units that can be utilized in a single project, so that different people can work together and significantly reduce the production time of these large imagery datasets. So I'll demonstrate the capability in the software as well. So as you can see, this is a large amount of data set that we have of As you can see in the ArcGIS Reality Studio, it supports distributed processing where user can support different types of machines that are in your organizations and utilize their GPUs and for the processing of your project. And you can create multiple cloud connection within your organizations to utilize your resources from within your organizations. So once the process is completed, here are the some products that it can generate and derive from the organization as well. So as you can see, this is a 3D mesh uh, created from an aerial imagery. This is a survey grade accuracy that imagery can generate. Now, I'll move on to the application area that ArcGIS Reality supports and what are the application that we can create using the ArcGIS Reality suite. So these reality mapping products enable organizations to conduct land surveys, access and response to disasters, monitor on-site activities, perform remote project inspection, support urban planning initiatives, and enhance security and surveillance operations. By creating a digital view of the environment, ArcGIS Reality helps improve situational awareness, operational efficiency, and decision making across various industries and government domains. Now, I would like to showcase a example of a digital twin that has been created. So here is the video. So in this video, we are looking at a real world example of a digital twin of Stuttgart, Germany, created using imagery collected over an area approximately 250 square kilometers. So we have created this product using the ArcGIS Reality Studio. So this use case demonstrates how reality mapping data captured from an aerial sensors can be transformed into an accurate, high fidelity digital representation of an entire city. As you can see, we can integrate meshes as well as different GIS layers. And you can also inspect that what is the layer that is presented on the real world ground, and you can inspect the area. As well as you can integrate different types of layers like BIM layers to demonstrate and do the analysis of your future planning of a particular area, or you wanted to reconstruct that particular area. You can do according to the urban planning scenarios as well. So as you can see, it has integrated BIM plus reality integration. Not only the 3D mesh of your overview, you can also integrate the underground layers that are present. For example, railway creation using an underground method. You can also integrate those layers for the planning purposes and the real world scenarios, or you can do the simulations. So this is an example. Now, as we move on to our solution, I will conclude the today's session. As we have seen how Esri's reality mapping ecosystem enables organizations to transform imagery into an actionable geospatial intelligence from drone, aerial, and satellite imageries to high fidelity 3D models, Gaussian splats, and digital twins. ArcGIS Reality Solutions provide the tools needed to capture models, visualize, and analyze the real world at any scale. By combining reality capture with analytical capabilities of ArcGIS, organizations can create accurate digital representation of their environment, improve situational awareness, streamline operations, and make more informed decisions. Whether the objective is urban planning, infrastructure management, disaster response, or security operations, a digital twin development, ArcGIS Reality provides a scalable and integrated platform to support these workflows. Thank you for your time and participation. We look forward to explore these capabilities further during the discussion, and you can ask the questions. Now I will hand over the session to Samkit sir. Over to you, sir.
Thank you, Ashish. Thank you, Abhishek, for this insightful session.